All right. Well, hello, everybody. Welcome to another day of AP Computer Science A live lessons. My name is Rob Schultz. I teach at Bellbrook High School in Bellbrook, Ohio.
And I'm Jill Westerland, and I teach at Hoover High School in Hoover, Alabama. We're so glad that you're with us today. Here is our big map of where everybody is. I hope that you can place yourself here and remember that you're our priority, and we like to keep in mind exactly who we're planning our lessons for. So welcome. Let's go over the exam information for 2020 quickly. We are like full on focus toward this year's exam. You will have two test questions. Question one will have 25 minutes, and it's the bulk of your points, 65% of your score. It will either be a question about an array or a question about an array list. So we're going to work all this week on arrays. Next week, we're going to be working on strings, and then we're coming to array lists. So those three topics, some combination of any of that would be question one. Then question two will be about methods and control structures. And as you can see at the bottom of the screen, these are formerly known as question three and question one that your teacher might have talked to you about all year. So your test day is going to be May the 15th, and you can see the times. Everybody in the world will be taking the APCSA exam at the exact same time. That's going to be the same across all subjects. So it's important for you to keep in mind the dates and your time zone and the timing there. You can read about that. We will talk to you in today's exam test prep tip at the end of class, and we're going to keep doing that every day about some different strategies. You do not have to use an IDE. You can use paper and pencil, paper and pen, and a phone to take a picture, or you could use an editor like JGrasp, JDoodle, Dr. Java, whatever it is that you're comfortable with, Eclipse. I'm trying to think. So those you could use, but you should not feel like you're going to have an advantage by using an IDE. And on the next slide, you'll see that there is a makeup date of June the 3rd. So if you have a true issue with May the 15th, do not panic. You'll be able to work that out through your school's AP coordinator and their connection to set the things up on that end. Test security, please know that there are measures in place to make sure that even though you're going to be taking this exam at home, that you're doing authentic personal work and you're doing it by yourself. So plan toward that. And we're going to talk tomorrow as well about these verbs at the bottom of the page. This is a snip from the course and exam description. But as you begin to ramp toward the test, it's important for you to look to the course and exam description to see every single thing that College Board has told us about the course and plan that way. So today you're going to be learning about traversing arrays. Yesterday's lesson, I talked to you about creating arrays several different ways and accessing elements of the array and defining what's in each element. Today you're going to learn about going back and forth and iterating or looping through an array. And you can see the free response questions that we've mapped for this week and our plan. So we hope that you join us each time and rewatch the lessons if you need to pick up concepts that maybe we talked a little bit quickly on the first time. All right, what we're going to do for warm up today is go through part B, which was your homework of the free response question that we finished class with yesterday. So if you remember, we talked about token pass yesterday, and it's a game. I think if you hit one more, there we go. It's a game where you have players. So the example shows 4 players, and you have these coins or tokens, and they're distributed to all the players. And if you remember from part A, we're going to distribute the tokens based on random number between 1 and 10 inclusive. So we worked through part A yesterday. Today we're going to look at part B. And if you notice, one more time, there we go. All of this question is based on a token pass class. And we built an array yesterday off of that class using the players in that class as part of our board. So player count is something that was fed into the question, and we use that as you were building the board. So let's look at part B. Part B, we're going to be doing the distributing of the tokens. So part A was setting up the board and the players. Part B is going to be giving out the tokens. And let's see, I think I might have, here we go. So the tokens are collected and removed from the game board at the player's current position. They're distributed one at a time. So this is during gameplay. This is not the initial distribution. This is during gameplay. So as a person's turn, if you remember me talking about yesterday, if it became my turn and I was the second player on the board, I would have all my tokens given away and I would start passing them out to the other players as we loop through the array. So it tells you that we're removing all the players' tokens at the current position, and then they're going to be distributed one at a time, starting with the player that would be, to my right or next to me. And so that's the part about higher position. And they're given out until we reach, till I don't have any more tokens left. So we're really going to be writing a loop structure to distribute these tokens correctly, starting with my position if I think about myself as current player and forward. And like I told you yesterday, looking at this test question, we have part B up at the top where you see the lines underlined. That's one way that the directions are stated. And then where I have this arrow pointing down at the bottom, this is a restating of the same directions, just in a different way. So you can read it both places. You may like the verbiage of one better than another, but it's the restatement of the same. So distributes the tokens from one position at a time until the highest position's reached, and then we start back over at 0. So now let's look at how the code would look to solve question B. And I hope you worked on this last night. So the first part of the solution is that next player becomes current player. So the person to my right, if I were current player, is going to become, the next player is going to become the current player. So in other words, it's going to iterate forward once by redefining of that variable. If you're not familiar with using the word becomes in replacement of the equal sign in computer science, please start doing that. It'll help you kind of say the algorithm or the programming statement in a way that might help you make sense. I learned that from a guy in Texas, and it has proven true for years. The second thing, number to distribute, how many tokens we want to give, is going to be the place on the board that is the current player. So ever how many player tokens a particular slot has, that's going to become how many we need to distribute, because remember, you're going to give them all away one at a time. And then the third part was the board position at current player, my spot, becomes 0 because I've already passed that number into number to distribute by creating that new variable. Okay, the next thing is you could use the while loop to this. This is really the best way to do it, because while the number to distribute is greater than 0, which means it's 1 or more, we want this thing to keep happening. And what's going to happen is that next player is going to become next player plus 1 so that we can continue to march through while it gets the remainder of being divided by the board length. And then every time that happens, we're going to add 1 to the board so that we can continue to march through the index of the array. And the third part is we're going to just subtract 1 from the number of tokens that we distribute. And this while loop will, of course, keep happening until we are down to 0 tokens. So that's the solution to B, or a solution. I wanted to give you some commentary about it from the chief reader for that year. You already kind of know about how it works. This was considered an average difficulty question. The mean score, the average score on this question that year was 4.16 out of 9. And on the issues, or common mistakes, it said many students made mistakes using math.random. And we're going to look at that again because Jill made a mistake with math.random. So everybody can make a mistake with math.random. Many students had issues with going out of bounds. And I know that Mr. Schultz is going to talk about that a little bit today in terms of traversing arrays, of not going outside the bounds and going off the size of the length of the array. And then students would benefit, the chief reader said, from practice with use of random number generators in various contexts. So I hope that you spend some time with the source code that I gave you yesterday, and you're going to see some more of it today about using math.random in different contexts. So how did you do? Hope you scored yourself. That half of the question was worth 5 of the 9 points. So hopefully you got some points. And between the two, you might have done better than the average that year. So that would be great if you did. All right, a little bit more, and then we're going to get to today's lesson. Yesterday's Power Up, you had some arrays that you were going to build. I hope that you did that. I hope that you looked at part A of the question, or part B of the question for homework 2. And I think we can go down to the next slide. And like Mr. Schultz said yesterday, we're going to be ramping up. We're staying course focused. I gave you my swimming pool analogy yesterday. We are in the array lane, swimming laps back and forth all week. We are sticking straight to the concepts from the course and exam description. And I gave y'all a notes page yesterday. This is actually, if you hit the thing one time, it should, there we go. So this is about version 4 of my random notes. I think we're going to be, the word of the day, y'all, is perseverance. I am that kind of person. Mr. Schultz is that kind of person. And we are assuming that you all are that kind of people. We are going to persevere until we conquer. What's another word? Tenacious. I'm definitely a tenacious kind of person. So if you'll notice a few things, I changed my second little arrow looking thing to optional. Doesn't require the import of java.lang.math. You can import it. If you use random.random, which is a whole other story that you could use, it functions a little bit differently. I think it does use the import, or maybe it's optional there too. So don't hold me to that. But typically in my room, we import this, so that's one thing I wanted to tell you. And then the second thing is I finally had corrected my little algorithm so many times that I finally just cut out a piece of index card and glued it on top. And I know I said it correctly yesterday, but I did not write it correctly. A math.random generated random number is going to be greater than 0.0 or equal to 0.0, but less than 1. So it's finally stated correctly. Mr. Schultz is giving me a thumbs up. It's finally stated correctly, but like I told you yesterday, we normally multiply this number by something to get it up out of the less than 1 state that it's in. And then you work with adding something to it to form the range that you want it to behave in. So and you'll see this again today, but there's a lot of different ways to multiply by this, add this to the end, anyway, math.random. So there you go. So I think we're finally to the lesson, so you can quit listening to me. Oh, I forgot to tell them, if I sound better today, it's because we've been schooled on clicking the correct microphone. I tried to ask them, do I sound less Southern now that I have the right microphone, but I don't think that part's going to change. So if I'm louder or I sound less Southern, it's all because this microphone. I was already using this. I just wasn't clicking the right thing on this end. So take it away, Mr. Schultz. I will be quiet.
You sound great. Okay, so for today's lesson, we're going to look specifically at array traversal. Now, one thing that will help you as far as prior knowledge would be array implementation. It's going to be easier to traverse array if you know how to create an array. So if you aren't comfortable with array creation and array array implementation. See, now I'm the one that can't speak. If you aren't comfortable at this point with array implementation, you might want to go back and watch yesterday's presentation first, because it'll help you to know how to create an array as we start looking at manipulating arrays and traversing arrays and doing different things with array elements. Okay, so that's our goal for today. Our goal for today is to traverse arrays and figure out how to manipulate array elements. Okay, so here's our lesson prep, and we're going to make this a very quick 1-minute lesson prep. This is some review of yesterday. I'd like you to write the code necessary to create an array called int array that contains 10 integers. And then I want you to fill just position 0 with a random value between -20 and +20. Okay, so I'm going to give you about 1 minute starting right now. Okay, that looks like it's been about a minute. So let me go ahead and put the 2 lines of code up that you would need to complete these 2 instructions. The first thing we're going to do is we're going to declare and initialize an array of ints that contains 10 elements. And then as Mrs. Westerland showed us yesterday, we can go through and we can specify a specific element in an array and set that value of that element to whatever number we want. And in this case, we're using the formula that we learned yesterday to fill it with a random number. And just some quick review, math.random gives us a value between 0 and 1, where it could be 0, but it'll always be less than 1. We're going to take that value in parentheses, so we're following order of operations. We're multiplying it by 41. And the reason we're multiplying by 41 is our range of values goes from -20 to +20. So if you're thinking, well, that's only 40 values. We have -20, +20. Don't forget 0 is in there as well. Our total range from -20 to +20 will include 41 possible values. So at this point, we're taking math.random, multiplying it by 41. So we'll now end up with a value from 0 up to, but not including 41. We're then going to cast that as an integer. So we'll get an integer value from 0 up to, but not including 41. And then we're going to subtract 20 from whatever we get. So that'll take our range of values from 0 up to 41 and shift it down so we get from -20 to +20. Now, yesterday, Mrs. Westerland showed us 2 different ways that we could fill an array. We could use an initializer list. I'm speaking too fast. We can use an initializer list, which gives us curly brackets, and we can put the value of each element inside the curly brackets. Or we could write a specific line of code like this. So I could say int array with brackets 0, int array with brackets 1, int array with brackets 2. And both of those are fine if my array is relatively small. I mean, that's okay if I have 10 values in my array. But if I get to the point where I've got 20 or 50 or 100 or 1,000 or 100,000, we really don't want to have to do an initializer list that contains that many values, and we definitely don't want to do that many individual lines of code. So the purpose of what we're looking at today is how we can use a for loop to repeat the instruction of doing some of these things that we want to do. And that's where we get into our array traversal. So first thing we need to look at is we need to look at the definition of what array traversal is. I mean, we can't really traverse an array if we don't know what it means to traverse an array. So this is the definition we're going to work off of. Basic array traversal is accessing the elements of an array from a starting point to an ending point for a specific reason. Okay, so everything we're going to look at today is going to follow that definition. We're going to access the elements of an array from a specific starting point to a specific ending point for a specific reason. Okay, so here's our first example. Let's go back to our array that we just created that has 10 integer values. And let's say now we want to put a random number between -20 to +20 in each specific spot, but we want to do it with as few lines of code as necessary. So take a look at what I put on the screen. You're going to notice a lot of similarity between this and what we're going to look at as we go. So looking at our definition, we're accessing the elements of an array I'm using my loop control variable I, which is referencing our index position, or it's using an index position. I'm giving it a specific starting point. We're going to start at index position 0, and I'm giving it a specific ending point. We're going to end when we hit the point that our index position or our loop control variable is equal to the length of our array. So I'm giving it a starting point, I'm giving it an ending point, and I have a specific reason. I'm going to use the exact same little formula that we used a second ago to fill int array position 0, but now I'm going to use it every time my loop control variable increments. I'm going to use that loop control variable to set the value of that array position equal to this value, to a random number between -21 and between -20 and +20. Okay, so the couple things I want to point out. Array traversal requires a loop. Okay, we have to have some kind of a loop that's going to take us from a starting point to an ending point. And inside the loop, we have to access the elements of the array. If I left this as just int array 0, then technically I'm not traversing the array. I'm just resetting the value of position 0 over and over and over again. So I have to make sure that I'm accessing the elements of the array, and there has to be some specific purpose to it. Okay, so we have to have those different pieces. Now, in my class, I'm gonna go into a little analogy, so bear with me. In my class, I like to tell my students that a programming class is kind of like in the old days. I don't know how many schools offer like wood shop, but in when I was in high school, I took wood shop with Mr. Fisher, and Mr. Fisher taught us how to use the tools of a wood shop. You know, obviously we had the basic hand tools: a hammer, a screwdriver, a chisel, a vise, I mean, different things like that. But we also used some bigger, more high-powered tools: a drill press, a belt sander, a lathe. I mean, different things that we could use in a combination of ways to build different things. Well, in Java programming, a lot of the things we do, we're kind of following that same idea. I mean, math.random is a tool, and array traversal is a tool. So as I learn to use all of these different tools, I can put them together and use them in different ways to build cool things. And what I'm going to show you with the next few slides is that basic array traversal, it has all of these same elements, but I can use it to do a lot of different things. Okay, the key is this: for a specific reason. Okay, well, the for a specific reason can mean a lot of different things. For example, with this one, I'm using basic array traversal to set each value in my array. I can also use, oh, there's what I would end up with. So this is the array we're going to kind of work from. I can also use basic array traversal to display each value. Okay, so I'm accessing the elements of my array from a starting point to an ending point for a specific reason. The specific reason is that I want to display each element in my array as I iterate through my loop. Okay, so with each one of these, I know that we're telling you to kind of take notes and write things down. So I'll give you a couple seconds with each one of these to kind of jot down, you know, what it is we're doing. You'll notice that the for loop stays the same for these examples, for, you know, pretty much all of the examples I'm going to show you. Basic array traversal, our starting point is going to be 0, and our ending point is going to be the end of the array. So really the only thing that's going to change is just the contents of the for loop. So we know how to fill an array. We know how to display each value in an array. Well, let's say I wanted to search for a specific value, and I wanted to display all of the locations that contain a specific value. Okay, well, without changing a whole lot, notice that my for loop stays exactly the same. I'm still going from the same starting point to the same ending point. I'm still accessing the elements of the array, but now my specific reason is a little different. If the value at my array position I equals -12, then I'm going to display the location. I'm going to display the value of I. So in this case, the output would simply be 5. 5 is the only location that has a value of -12. If I want to go on and modify this a little further, let's say I want to count the number of occurrences of a value. Okay, well, the one thing I have to add up here is anytime I'm counting something, I have to have a variable to keep count. So I have to declare and initialize a variable called counter. My for loop, again, is exactly the same. I have a starting position, I have an ending position. I'm accessing all of the elements of the array. And if by some chance the value of an element equals -12, I add 1 to my counter. Okay, so again, I'm using the same basic tool. It's just I'm tweaking it a little bit each time so that that specific reason that I'm using it for becomes different. Okay, I can use array traversal to accomplish a lot of tasks. All right. The next two examples I'm going to show you, I'm going to slow down and we're going to work through in a little more detail because they're going to apply specifically to the free response question that we're going to look at in just a minute or two. All right. Let's say I want to look through my array and I want to find the smallest value. Now, again, I want an algorithm that I can use that'll work for 10 elements or 10,000 elements, and it won't matter. All right. So here's what we're going to do. I'm trying to keep track of a minimum value. So again, I have to have a variable to store that minimum value. You'll notice my for loop hasn't changed. I'm still going from my same starting point to my ending point. And the way this algorithm works is as I'm working my way through, if I find a value that's less than whatever is stored in min, then that value becomes the new min. It's kind of like playing tag. You know, if I find something that's less than min, then that new value is it. It becomes the min. So I've also had students who in the past, when we do a little algorithm like this, they'll set min equal to 0, or they'll set min equal to, I don't know, kind of a variety of things, but it's always a good idea to assume starting, and again, this kind of goes back to those keywords that we looked at that you're going to find on free response questions. We're going to start by assuming that our first actual value that we can look at and access in our array, we're going to assume that's the minimum value. And then we're going to give the algorithm a chance to prove us wrong. Okay, but if by some chance we traverse the entire array and we don't find anything less than min, well, we know that we've still got a minimum value because the value that we first set to min is the first actual value in our array. Okay, so let's work through this one together. We're going to do this one step by step. Okay, first thing we're going to do is we're going to define a variable called min, and we're going to set the value equal to whatever the value of int array position 0 is. And then we're going to iterate through our loop. And every time we pass through our loop, we're going to check to see if the value at int array position I is less than min. In this case, 10 is not less than min, so we skip it. 17 is not less than min, so we skip it. -5 is not less than min, so we skip it. 20 is not less than min, so we skip it. But then we hit -12, and -12 is less than the value that we previously had at min. So min becomes -12. And then we continue to cycle through because we don't know what comes after that. So there's no guarantee that -12 is our minimum value. So we keep going. So now we're comparing to -12. 5 is not less than -12. 14 is not less than -12. 13 is not less than -12. But then we hit -19, and -19 is less than -12. So that becomes min. And finally, we come back up. We increment our loop control variable one last time. So now it becomes equal to int array.length, which is no longer less than int array.length. So we jump out of the for loop, and min contains the value of our minimum value. All right. Now, like I said, this one's important because, again, it applies directly to what we're going to be doing in our free response question in just a second. If I want to find the maximum value, the algorithm works the exact same way. I'm going to define a variable called max. And again, for safety's sake, I'm going to assign max the first value that's in my array. And then I'm going to give the algorithm a chance to prove that that's true or not true. Okay, so again, we're going to work our way through. The first one we look at right off the bat is greater than -8. So 10 becomes our new max. And then I jump to the next one. Well, 17 is greater than 10. So 17 becomes our next max. -5 is not greater than 17, but 20 is greater than 17. So 20 becomes our new max. And then I continue to work my way through looking for anything that's greater than a value of 20. And in this case, there is nothing greater than 20. So I get to the end of my array. I've traversed the entire thing from the starting point to the ending point. And by the time I jump out of my for loop, max has the value of our maximum value in our array. Okay. All right, so hopefully everybody was able to follow all those. I know we're encouraging you to take notes. I probably went through those a little quicker than I should have, but the nice thing is these are being recorded. So if there's anything that you didn't quite get, you can go back and rewatch the recording and make sure that you've got those little notes down. Again, the main thing I wanna make sure that I make clear is that it's a for loop with a starting point and an ending point. I'm accessing the values of the array inside the for loop, and there has to be some specific reason. There has to be a purpose for doing it. Okay, so let's jump ahead and let's take a look at our free response question. I love this free response question. This is from the 2010 exam. This is question number 3, the hiking trail question. Just a basic description of the problem. It tells us that a hiking trail has elevation markers posted at regular intervals along the trail. And in Bellbrook, one of my favorite hiking and running trails is our Sugar Creek Reserve. And it doesn't show elevation. I mean, we're relatively flat at Sugar Creek Reserve. There are some smaller hills, so we don't have elevation markers, but we do have markers kind of along the path that tell us when we've gone certain distances and things. So I can kind of relate this. But I'm picturing a trail where maybe we're increasing, decreasing elevation quite a bit. It goes on to tell us that elevation information about a trail can be stored in an array where an element in the array represents the elevation at a marker. So the elevation at the first marker is stored in position 0, the next marker is position 1, and so on and so on. So they give us this nice chart that shows the elevation of a sample trail. Okay, so again, I want to stress that we're not building our code specifically for this one and only example. We have to make sure we're building it for any trail array that they could give us. But for this example, they show us a graph that shows our elevation, and then they show that data converted into a table. So at marker 0, our elevation is 100 meters. At marker 1, our elevation is 150 meters, and so on and so on and so on. Okay, so looking specifically at the declaration of the trail class that they give us, our job is going to be to write 2 totally unrelated methods for the trail class. So they give us some different things. Okay, they give us a private instance variable, an array of ints called markers. And I want you to notice that we're declaring it as a private instance variable, but we aren't constructing it. I'll get back to that in a second. They're giving us a method header for the first method that we're going to write, the Boolean isLevel trail segment method, which takes 2 integer parameters. And then we also get that method header for what we're going to write in part B, a Boolean method called isDifficult. Now, I made the comment a second ago that we're declaring markers, but we're not actually constructing it. And you'll notice that we aren't given a constructor in here anywhere, but there's a little note at the bottom that says there may be instance variables and constructors and methods that are not shown. Okay, so what that means is we can make certain assumptions about things that are taking place in this class. We don't have to worry about the implementation of those things. Okay, the only thing we're going to worry about is writing the method isLevel trail segment and isDifficult based on the specifications we're given. The main thing I wanted to point out is that we have to be careful because we aren't doing the constructor, which means we won't necessarily know the length of markers until we go to use it. Okay, so we can't specify. And again, this kind of goes back to saying that we're not looking specifically at the one and only example we were given. We could have a trail array that has 5 elements or 50 elements. We don't know because we aren't writing the constructor. Okay, so we have to be able to accommodate any length trail that we possibly can. The only thing that we know at this point is the precondition that we're given, and this is something that we don't have to test. We can assume that this is a true statement. We are going to be given an integer array called markers that has values in it. Start is going to be greater than or equal to 0. So 0 will be less than or equal to start. Start will be less than end, and end is going to be less than or equal to markers.length minus 1. So those are the conditions they give us that we know are going to be true before we even start to implement this thing. Okay, so let's take a look at part A. I have to be careful with our time. We're down to about 10 minutes left. All right, so our job is to write the trail method isLevel trail segment. Okay, it tells us that a trail segment's defined by a starting marker and an ending marker. Those are our parameters, and all of the markers in between. The parameters of the method are the index of the starting marker and the index of the ending marker. And then it goes on to tell us that a method will return true if the difference between the maximum elevation and the minimum elevation in whichever segment of the trail they give us is less than or equal to 10 meters. Okay, so we're going to have to pick a starting point, pick an ending point, find the maximum, find the minimum, and determine if the difference between the max and min is less than or equal to 10. Okay, so they've given us a couple different little samples here we can look at. So it says for the trail shown at the beginning of the question, for that specific example, the trail segment starting at marker 7 and ending at marker 10, so we are including our ending marker, it has elevations ranging between 70 and 80 meters. 70 is our minimum elevation, 80 is our maximum elevation. And because the difference between 80 and 70 is equal to 10, which falls into our less than or equal, the trail segment is considered level. We would return true. If I look at the trail segment that starts at marker 2 and ends at marker 12, it has elevations ranging between 50 and 120 meters. And because the difference between 120 and 50 is greater than 10, then this trail segment is not considered level. Okay, so again, we have to find our minimum value, our maximum value from our starting position up to and including our ending position. Okay, so I'm going to give you, we're down to 10 minutes. I'm going to give you, let's say 3 minutes. That probably isn't enough time, but if you're watching this as a recorded lesson, feel free to pause to give yourselves a little more time. Okay, I want you to take a look and see if you can write the is_trail segment method based on the examples that I showed you just a couple seconds ago. Go ahead and go. All right, we're almost at the 1 minute mark. So I'm going to kind of give you a couple little hints as we go here just to fill the dead air. Think about when we did our algorithm to find the min and our algorithm to find the max. In this case, we need to do both. So think about the things that went into those examples. We need to identify a variable that's going to hold our minimum value. We need to identify a variable that's going to hold our maximum value. We need a for loop. And then we need to access the elements from our starting position to our ending position with a specific purpose.
So I've been taking notes today while you've been talking.
Okay.
I know. So
awesome.
I know.
See,
so
you're
they're
such a
probably
good...
writing code, but I'll just keep adding to our journal notes folder over there. But I'm determined for everybody to learn how to take notes before they go to college.
See, I think that's why we complement each other so well, because you are an amazing note taker, and I always had to kind of work at that. I mean, I took notes, and but
well,
you
if
know,
we had been in college together and we were in the same study group, it wouldn't have mattered. You could have just had my notes copied and added to them, right?
Well, yeah, but still, even if you're using somebody else's notes, you still need your own notes.
Taking them down yourself is
yeah
part of the drill.
Yeah. I have students in my class that will take notes, because I do notebook checks, and I especially in my intro to Java class, I require them to take good solid notes. We're down to about 25 seconds left, by the way. So I do notebook checks, and I have a rubric that I give them, and some students, they try their hardest, and they do a good job. But I have other students that it's like a science. They have different colors and highlighters and colored pens, and I mean, they're beautiful, beautiful notes. Amazing. Okay, we're at the end of our 3 minutes, so I'm going to kind of cut off our discussion here. Let's start working our way through this. We said that because we're looking for a min and a max, we need a couple different things. Okay, we need a variable that's going to keep track of our minimum value. We need a variable that's going to keep track of our maximum value. And we said that just so that we can be sure that we have something in our array as our min and max, we're going to start with min and max both being set to the value at our starting position. And then we're going to let our algorithm prove us either right or wrong. We're going to make that assumption that the value at position start is the min and the value at position start is the max. And then we're going to let the algorithm do its thing. Okay. At the very bottom down here, we said our goal is to find the difference between max and min. And if that difference is less than or equal to 10, this is going to result in a value of true. It's a Boolean expression, so it'll be either true or false. And we're going to return whatever is, whatever the result is of this Boolean expression. So if this works out to be a true statement, we're going to return true. Otherwise, we return false. Okay. We said we also need a for loop. And in this case, our starting position is the parameter start. Our ending position is the parameter end, but remember the precondition that said that end will always be less than or equal to the length of our array minus 1. So we are guaranteed that even if we go up to and we include end, we won't go out of bounds. Okay, we want to make sure that we're staying inside the boundaries of our array so we don't get any bounds errors. All right, so we're going to start at position start. We're going to go up to and include position end with our loop control variable, our index position. And then the last thing we need is our two little if statements that we had for our find the min, find the max. If whatever value we happen to be looking at is less than min, that becomes our new min value. On the other hand, if whatever value we look at is our max, is greater than our max, it becomes our new max value. And we don't necessarily want this as an if else, we want these to operate independently of each other. We're looking for two independent things, so we don't want those linked together. So here's our algorithm. Now, I purposely didn't provide the points off of the scoring guidelines for this one because in 2010, scoring was a little different. In 2010, we used half points, and I was afraid that showing you half points would confuse things a little more than it helped. So, so I purposely didn't include the point values off of the original rubric for this just because scoring was a little different. Okay, we are down to 5 minutes, so I'm going to pick up the pace just a little bit. Okay, here's our debrief and summary. An array traversal involves accessing the elements of an array from a starting point to an ending point for a specific purpose. And the other thing I wanted to make sure I made clear today, that array traversal is a tool and it can be used for a wide variety of problems. Okay, here's our tip of the day. Okay, we said we were going to include a tip of the day. And so today's tip is taking code from your IDE, copying it to a Google Doc, and then downloading it as a PDF. All right. And there are several steps to this. The first thing that you need to do is turn off all of the auto formatting settings in your Google Doc. And I'm going to walk you through each of these steps in just a second. Okay. The second step is going to be to copy from the IDE and paste into your Google Doc. And then the third step will be to download from the Google Doc as a PDF. Okay, so step one, turning off all of the auto formatting settings. In your Google Doc, you want to click Preferences in the Tools menu. Once you get to Preferences, you're going to tell it you want to turn off all general settings. And it's going to bring up a little pop-up window like this with all of these checkboxes. And I believe by default, all of those are checked. We want to go through and uncheck everything. We do not want to automatically capitalize words or use smart quotes or detect links. We don't want to do any of those things. Okay. The second thing you're going to do is you're going to go back to your IDE. You're going to highlight the code in the IDE, which the easiest way is to click somewhere in the code and click Control-A. That selects all. We're going to select Copy, and the fastest, easiest way is Control-C. You're going to click in your Google Doc, and you're going to select Paste. And again, the fastest, quickest is Control-V. So this is something you're probably going to want to practice a little bit. The last step is going to be to download as a PDF. All right, so to do that in your Google Doc, go to the File menu and select Download. Select the PDF option, and it's going to look kind of like this. You're going to go to File, you're going to select Download, and select the PDF option, and it'll take your code from the Google Doc and download it as a PDF into your Downloads folder. Okay, here is today's power-up. I feel bad because I feel like we're rushing, but we've only got a couple minutes to go. Remember that all of your power-ups and files that go along with today's lesson are out at bit.ly/CSA_exam review 2020. We're going to look at part B, and I'm going to kind of walk you through part B quickly. We're going to finish the method is difficult. It says a trail is rated by counting the number of changes in elevation that are at least 30 meters up or down between two consecutive markers. So we're going to traverse the array again, but we're looking for something a little different this time. We're going to keep track of the number of consecutive markers that have a difference of at least 30 or more. And if we have a trail that has 3 or more of those, then that becomes a difficult trail. So we're going to return true. This trail would be rated difficult because it has 4 changes in elevation that are 30 meters or more, as you can see. So I'm going to give you some time to think about this one. I want you to look at it overnight, and then we'll go over the solution tomorrow. Mrs. Westerland, I'm going to turn things over to you for the last couple minutes here as we get.
And if you want to look at the whole question, the link to the repository for release for response was in yesterday's Power Up, or you can certainly find it. We've shown you a couple of times how to find it. So here are some pets. Summer has kittens. Scout and Harley live in Phoenix, and it's so pretty and sunny there. And then there's a teacher from Phoenix who has that pretty cat. So Thanks for sharing
Okay,
those.
I've loved all of the pets that we've seen so far, but
Yeah,
this dog is
isn't
adorable.
he cute?
And
It
this one
looks
is
like
too.
it's a little bit of Saint Bernard or something. I
Yeah,
can't tell.
yeah.
I like the name Scout because who doesn't love,
Oh yeah,
Scouting to Kill a Mockingbird?
yeah.
And I think we just have our device. If you need device help, go to cb.org/tech, and then our thank you. So
Yeah,
it
and
was
that's
another
it.
bell to bell.
Boy, we
So
cut
thank
this one
you
right
for
down to
being
the
with
wire.
us. Yeah, come
Sorry,
back tomorrow.
sorry I had to pick up the pace there at the end. We hope
That
everybody
was
had a great
good.
day, and yeah, we'll see you all tomorrow.
Take care, guys.